Yeah. Good afternoon, all. So before I start, can anyone please confirm whether my voice is clear?
Yes, clear.
Uh, Fine. And is my screen visible to all?
Yes,
So PySpark. So in the last demo session, just I was discussing about what is Apache Spark, why PySpark, need for PySpark, PySpark Python versus Scala, and PySpark features, and real-time usage of PySpark and PySpark job market, right? And first, starting with evolution of, just I'll take some time to just say about this Apache Spark and evolution. Evolution of Apache Spark. It was developed by Meta is a area in AMP Lab Berkeley in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. And as Spark, it's I can define Spark in 4 lines, right? It's a distributed execution framework in parallel process style with in-memory computation used for large-scale data processing, right? In-memory means storage and processing both happening at the memory level. So storage at the and processing at the, that's why like memory in-memory computation. Spark used for data analysis, processing, and computations, right? So I can say it's a general engine for big data analysis. It's an open source distributed cluster computing framework introduced by Apache Software Foundation, right? And why PySpark? Why PySpark means it is a Python API to use Spark, right? PySpark is a Python API to use Spark. So as said, it's an open source cluster computing system used for big data solutions. So I said like PySpark is the technology that is designed for fast computations. It's a very demanding tool for among the data engineers to work with the bigger data sets. So generally PySpark used for distributed SQL. It's used for distributed creating data pipelines and ingestion data into database and ML algorithms and graph and data streams. Okay, so today like data is generating enormously, like huge data, like in TBs, petabytes of data, right? So as data is growing, right, we need to have some proper processing tools to process it for performing different set of operations on huge data sets. So so you can see the data generating both in offline and online, right? There we get some hidden patterns, unknown corrections. We have got some market kind trends, customer preferences, other useful business informations. So it is it's very much required to extract some valuable informations from the raw data, right? So we require some efficient tools to process the data in quick time, right? Very fast computations required. So PySpark is one of the solution. And so here we have got some, it's one of a flexible tool to crack the big data and gain benefits from it. So the combination of Python and Spark would be an efficient way for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Observe this PySpark, right? Spark plus Python. Spark plus Python, right? PySpark, nothing but Spark plus Python. So Spark, generally Spark can also be coded with, Spark can be coded with Scala, Python, Java, and our language. Scala is the default. Spark built by default by using Scala language. And if you see the differences between Python and Scala, Python is dynamic typed, Scala is static typed. Means here no need to specify the data types here in Python, but here, okay, val x, val y, right? But here directly what value you are assigning to, what value you are assigning, right? Based on the values assigned, the variables are created accordingly, right? Yes. Type of x is int, why it is int, because you assigned the integer value. Type of y is float, Why it is float? Because you assigned a float value to it. Python is open source and has got large community, but Scala doesn't have the it's a small community, right? Python has powerful libraries for machine learning, graph algorithms, right? So Scala has less as compared with Python. 89,300 inbuilt models for various domains, but it's used only for Spark. So here Scala is only, it's a native language of Spark, it's used only for Spark. But Python has got models for various domains. PySpark features lazy evolution, means on demand we can execute, right? On demand we execute. In-memory computation means storage and processing within the memory level. Fault tolerance. If multiple slaves running parallelly, suddenly if any one slave machine is down, then the task of it, okay, will be okay. How it is going to recompute it, right? Without any job failure or task failure. Persistence means executing the transformations. The executed transformations can be reused. It's immutable. The original data set won't be modified. It will be remains as it is, right? Real life use cases of PySpark, right? In commercial sector, right? PySpark is mostly preferred today, right? For in the financial fields of financial sector, we use Spark to retrieve most of the customer social media profiles and same gain some useful insights which can help to take the right decisions. Healthcare. So in healthcare also, I was just saying that patients records and their history, that is medical history, and their reports to identify which patient is going to face a kind of problem. In entertainment industry also, right? So like in OTT, in online, like online platforms, like online entertainment platforms or OTTs, just like Netflix using Apache Spark for real-time processing for personalized online movies or web series. It process, I said, like it is going to process Netflix. So Spark is going to process nearly 450 billion events per day that are streamed over the server side applications. And within the trade and e-commerce also, right? Like Flipkart, Amazon, all the social media sites using Apache Spark for this advertising, right? Like enhanced customer experience and optimizing the overall performance. In tourism industry also, right? Apache Spark providing advices to millions of travelers, right? Okay. And here, why we choose Python? Why we choose Python for this implementation, right? Python has got very less coding as compared with other programmings like Java, which has complex codes and very huge codings. Simple syntaxes like Python, which looks like normal English statements. Hybrid features like multi-programming features, right? And I say like multi-programming features. Multi-programming features it has got, right? It has got the features of procedural oriented, like C language, Python features I'm talking, right? Yes. Object oriented, right? Object oriented programming. It has got the features of C++, Java. Object oriented, it has got the features of scripting. Can write many scripts, right? Scripting features like shell script, and it has got the features of modular programming, right? Okay, if you combine all this, right, nothing but Python. So it has got my multi-programming features. So like hybrid features, interactive mode. We can easily interact with Python statement by statement. We interact with Python statement by statement, gives response for every statement, right? You go to this command prompt and just type Python and just check, say enter, and you will get this Python interpreter gets open. Any valid Python statements you can type and check. 5 plus 3 I'm asking. It gives the response. 6 into 8 gives the response. X as 10, Y as 4. What is X? What is Y? What is X plus Y? What is X minus Y, right? X into 2. 10 into 2, 20, right? 10 to the power of 2, X to the power of 2, 10 square. So in this way, X equal to any valid Python statements you can check, right? How simple. And line by line execution interpretation, we say, right? X into 3 prints hello for 3 times. X into 5 prints hello for 5 times. Quit, you can come out of this, right? This interact. Many built-in libraries, 89,300 models for various domains, for data science, big data, for animations, gamings, embedded applications, network applications, right? So I was just talking like Yahoo has taken a table to check the speed of different databases, other things, right? Has taken 100 TB consisting of 1024 columns, right? Sorting based on the task was sorting based on 16 columns. Time taken by different databases. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours, right? Teradata can handle TBs of data, right? Netija only just it has taken 3 hours. Hadoop has just taken, see, all this has taken days and hours, right? Hadoop has just taken 3.4 minutes, right? And processing. But here, if we talk, Spark is 100 times faster than Hadoop. I'm saying like it's 100 times faster than Hadoop. All PySpark is mainly designed for, it is mainly designed for batch applications. Batch applications, it's not for online applications. Batch applications means user non-interactive applications. Online applications means user interactive applications, means user gives the input there. Okay, so user non-interactive applications, user interactive means like online applications. It's not for online applications, it's for batch applications, for millions and trillions of records, right? Iterative algorithms, most of the machine learning algorithms are iterative. We keep on applying that algorithms, right, until that error becomes zero. Interactive queries, SQL queries, right? And for streaming. And features and advantages of Spark, PySpark, right? And very high speed processing and in-memory computation, distributed execution, multi-language support, supports advanced analytics and parallel processing, and persistence feature, powerful, fault tolerant, right? Yes. Today I discuss about Spark data objects, right? Spark data objects. One second. One second. So something about ODDs. ODD. You need to know something about ODD, right? We call it as resilient distributed data sets. Resilient distributed data sets. Observe like Spark data objects. Spark data objects are called as RTDs. Observe, what do you mean by an RTD? Resilient distributed data sets. Spark data objects are called ODDs. RTDs are subdivided, or they are subdivided into partitions. These partitions are distributed. They are distributed across multiple RAMs. These partitions are distributed across multiple RAMs of multiple slave nodes of multiple slave nodes. These partitions are distributed across multiple RAMs of multiple slave nodes, CPUs, right? Here the advantage, what advantage we can observe here, the advantage is bigger data sets, or bigger or huge data sets. Bigger data sets means RTDs. Can be loaded into RAMs. Okay, Spark data objects we call it as RTDs. RTDs are subdivided into partitions. These partitions distributed, they are going to be distributed across multiple RAMs of multiple slave nodes. So bigger data objects, RTDs also can be fit into this RAM. So here, if you talk about more on this RTDs, RTD programming style, RTD programming style, right? Is a data flow, right? Yes. RTD programming style is data flow. What is a data flow? Is a sequence collection of pipes. Data flow, RTD's programming style is data flow. Data flow is a sequence collection of pipes. Pipes means RTDs, I can say. ODDs. What do you mean by a pipe? A pipe is a data operation, like the operation can be loading the data. A pipe RTD is a data operation. The operation can be loading the data, transforming data, filtering data, sorting data, merging data, etc. Right? A pipeline and an RTD is a data operation. The operation can be loading, merging, sorting, right? All this, right? Yes. In Spark, right? In Spark, data flow is executed. Data flow is executed in sequence. In Spark, data flow is executed sequentially. That is RTD by RTD. That is RTD by RTD. one after the another, one after the another. With in-memory computing. In Spark, data flow is executed sequentially, that is RTD by RTD, one after the another with in-memory computing feature and persistence feature. Right, more on this in-memory computation and persistence I'll be discussing, right, with multiple examples. For example, I got RTD1, assume that RTD1, RTD2. These RTDs, these RTDs cannot execute in parallel. These two RTDs, right? These two RTDs cannot execute in parallel. But if the RTD has, but assume if the partitions has 20 partitions, if the RTDs, sorry, if the RTDs if the RTDs has 20 partitions, then these partitions can execute in parallel, right? Yes. RTD1 is there, partition 1, it is divided into partition 1, partition 2, partition 3, partition 4, partition 5. Same way, 20 partitions. P1 stored in slave 1 system 1 or P2 stored in system 2. All these 20 partitions, right? All these 20 partitions can execute parallelly and use the output, right? So the output of RTD1, the output of RTD1 is the input to RTD2. The output of RTD1 is the input to RTD2. Observe. Okay, just observe this diagram, right? Yes. RDD1 into multiple partitions. RTD1 into multiple partitions. P1, P2, P3, P4, P5, so on, right? P20, assume. Okay. So the output, whatever you get, so this P1, P2, P3 partitions will be distributed across multiple ramps of multiple slaves, and they are going to get executed parallelly. You will get that output. You will perform. So at each RTD, either loading data or transforming data or filtering data or merging data, any some kind of operation is going to be happen, right? So here, if you see the output of this is the input to the next one. The output of this is the input to the next one. This is RTD2. In the same way, RTD2 is there. RTD2, again, you perform some kind of filtering or merging, some operation you can perform. This output will be the input to the next one, right? Yes. Okay. The output of this is the input to the next one, right? That is the input to the next RTD. RTD by RTD, all the RTDs are not going to get executed parallelly. They execute sequentially one after the other, but the partitions which each RTD has got, that will be executed parallelly, because RTD1 and RTD2, if they execute parallelly, then RTD2 cannot get the output, that cannot get the input, right? Once RTD1 totally executed, then the output is taken as input, right, by the next one. Until then, the RTD2 cannot execute. Okay, here if you observe, if we perform action, then only the entire flow executes. If we perform action, then only the entire flow executes. That is what we call it as lazy evolution. Lazy evolution, right? Yes. Then only the entire flow executes. If you're not performing action, then the flow is not executed. It's not like an automatic process, right? Just ODD3 dot action, then the flow executes, from RTD1 to RTD3. Okay, that is what RTD, every data object is an RTD, right? Yes. One second, observe this one more diagram. Okay, so okay, that's fine. Before that, right? On RTD, two type of operations can be performed. On RTD, two types of operations can be performed. First one is transformations. Second is like actions. And RTD, two types of operations can be transformations and actions. Talk about these transformations. Three types of transformations, right? We have got three types of transformation. Yes. Each element of transformation. Example, map using map and using flat map. Example of each element transformation means map. For example, you got 1 lakh records, employee records or customer records, right? I want to transform each name, employee name, to start with first character as uppercase and remaining all in the lower cases, right? First one is what each element transformation means. If 1 lakh records employee names or customer names, each and every name, first character only in the uppercase, remaining all in the lower cases, you go for each element transformation. I want to give hike to all the employees. Otherwise, I want to give bonus to all the employees. I want to give a bonus of 5,000 to each and every employee. So each element transformation means each record is going to be transformed. Means 5,000 is going to be added to each and every employee record, right? So such kind of things we call it as each element transformation. Filter transformation. Filter transformation, right? Yes. Example, filter we have got, filter by range we have got. So filtering based on condition, right? I want particular city or particular product or particular year, particular branch, right? In such kind of transformations. Aggregated transformation. Aggregated transformation, right? Yes. Example of aggregated transformation, like we got group by key, right? Yes. and reduce by key. These things we'll be discussing in brief. Reduce by key, right? Yes. Okay, these are three types of transformations, right? Either on each RTD, either you'll be applying these kind of transformations. Second is like actions. Actions, right? Yes. Whenever you perform action only, then the entire flow will be executed from the root onwards to that, right? When an action is performed, right, on a RTD, then only the entire data flow, then only the entire data flow will be executed from the root RTD, right? Yes. When an action is performed, then only the entire data flow will be executed from the root RTD. So let the following are some of the actions, right? The following are some of the actions. Just I'll show some of the actions now. Later we'll discuss in brief about the actions and transformations. Later now I'll be providing some kind of examples how these RTDs are computed. Collect. We'll collect all the partitions data. We'll collect all the partitions data of different slaves. Into client machine. We'll collect all the partitions data of different slave machines into client machine. Example, right? RTD.collect. Second, some more action, like count. Counts the number of elements in a RTD.count. RTD.count, right? Yes. Counts the number of elements in a RTD.count. Next, take. Takes first a number of elements in a RTD. Similar to limit in SQL, right? Similar to limit in SQL. RTD dot, so here if we can say example, right? RTD dot take of 10.
Hello.
Hello.
Yes, sir. Can anyone please confirm whether my voice is clear? It's audible.
Yeah, audible.
Fine, thank you.
Yes, sir.
Fine. So if partition one having, see here, RTD.take 10 takes first 10 records. If partition one having only 5 records, then it takes the other 5, partition 2. Yes, it takes the other 5 from partition. And one more, right? Save as text file. Save as text file. Storing the results, right? Storing the results. Into a file. Storing the results into a file. LFS or HDFS. How to distributed file system? HDFS, right? Save as text file, storing the results into a file like LFS or HDFS, right? Just observe this example. Just observe. You can just observe this example, right? How the RTDs are computed. So here, okay, I just discussing there are two types of things you can perform, like transformations and actions. On RTD, we can perform two things, or transformations and actions. Transformations, 3 types. Okay, actions, like these are the types. So if you perform an action, then only the entire flow executes from its root, otherwise not executed. So for example, R1 or DD1, right? Or DD1 is created. How are, so using Spark context, using text file, right, and give the file path. How this RTD1 is created means using the text file, give the file path, then RTD1 is created. If you are loading a file using Spark context, then RTD1 is created. And after that, what you do on this RTD1, I am performing some kind of map operation, mapping each element to start with uppercase. Okay, some map functionality is given, right? Yes, some transformation, map transformation. The resultant, whatever you get from any transformation, right? It's also an RTD. RTD2 equal to RTD1 dot map. The output of what you get from this RTD1 is nothing but input to RTD2. And on this RTD2 already existing, now you got RTD2. On this RTD2, if I'm performing some kind of filtering operations, filtering based on city or filter based on product or based on year, right? The resultant what we get is an RTD3. RTD3 is taking the output of RTD2 as input. And again, on this RTD3 dot grouping or group by operations, right? Or group by key. RTD4 is created. RTD4 is created, right? So if you want to execute this entire flow, okay, one last one, right? Yes, on all this RTD4 got created. RTD4, you can perform some kind of another map operation and map each element with some, okay, Where these 5 RTDs are stored? Where these 5 RTDs are stored? Otherwise, so here if we perform action, where these 5 RTDs, yes, where these 5 RTDs are stored, yes. What is your answer?
In RAM.
Memory.
So observe carefully here. If you have got some 20 RTDs or 30 RTDs, all the 20 RTDs, 30 RTDs cannot be accommodated by RAM. Think that one RTD size is like 1 TB. If you think a bigger RTD, bigger
Cloud.
data. So this 20 RTDs cannot be accommodated by RAM. That much space won't be available in RAM, right? So where these 5 RTDs are stored means nothing.
Cloud.
Yes, any query? Any query? Okay. They are stored where these 5 RTDs are stored means they are stored or loaded. They are stored or loaded only when action is performed. See here, they are stored or loaded only when action is performed. They are stored or loaded one by one, only when action is performed. One more query, right? Just one more this. One more query. After the execution, right? After the execution is completed, how many RTDs in the RAM? After the execution is completed, how many RTDs in the RAM?
Zero.
Zero, right? I'll say that we're taking some example. I'll just say how why zero RTDs means one by one they will be loaded, one they will be deleted. Finally, once the execution completed, everything are going to be deleted, right? So here first RTD1 data is loaded into RAM in RTD1. RTD1 input output as input, right? It is taken as input, right? RTD2. Observe here, assume 100 record, 101, okay, 1000 records. When RTD2 is ready, RTD1 is removed from the RAM. When RTD2 is ready, then RTD1 is removed from the RAM.
Sir, so these things will be happen after putting action.
Action only. When they are stored or loaded one by one into RAM, one by one into RAM. Only when action is performed. If no action, they are not be loaded into the RAM.
So when we like till that time where it will be like whatever.
So they are just declared, they are just defined, right? So they are not stored, they are not loaded. So they'll be loaded one by one only when. So first, what do you mean by RTD1, RTD2, RTD3? How RTD2 is created? The RTD1, if you perform any operation, the result what we get is RTD2. First, only this file is available, file path. Only the single file is available. From the single file, RTD1 got created. From RTD1, RTD2 got created. From RTD2, RTD3 got created. From 3, 4 got created. From 4, 5 got created. Means if you're performing some operation on this RTD1 mapping, some transforming, right? Then the output what we get is nothing but NU RTD2. And on the RTD2, right? So all these 5 RTDs won't be loaded simultaneously because RTD1 and RTD2, if they are loaded, RTD2 cannot get the input until RTD1 its computation finished and gives the result. Then only then RTD2 can compute. But RTD3 input is what? RTD2 output. Until they get computed, they cannot give result to the next RTDs. If all the 5 RTDs loaded and they are going to be processed parallelly, the other RTDs cannot get the inputs. If RTD1 computed, only RTD2 can get the input. If RTD2 computed, then only RTD3 can get. That's what data flow means. That is what data flow. Data flow means the output of one will be the input to the next flow. All the flows means all the RTDs, all the pipes can't be executed in parallel. All the pipes can't execute in parallel. First pipe output is the input to the second one. Okay, 1000 records are there, right? I'm performing in RTD3. Observe this RTD3 output will be the input. RTD3 filtering operations here. Filtering operations. When RTD3 is ready. Okay. After filtering this output, think that you got only 500 records. Is taken as input by the RTD4. In RTD1 data loaded, RTD1 created. On RTD1 it performs some operation, right? RTD2 got created. When RTD2 is ready, RTD1 get removed from the RAM. When RTD3 is ready, then RTD2 gets removed. When RTD4 is ready, right? Once the total execution finished, once the total execution finished, then RTD4 also gets removed. Once the total execution finished, it collects the output. And now no RTD in the RAM. Now no RTD is in the RAM. Observe this, right? Yeah. R1, R2, R3, R4, R5, R6, R7, R8, R9. Here there are 3 flows, right? Here 3 different flows. First flow, R1, R2, R3, R4, R7. Second flow, right? Second flow, R1, R2, R3, R5, R8. Is the voice clear to all? Once again, can anyone please confirm?
Yes, sir.
R1, yes. R2, R3, R6, R9. Okay, there are 3 flows, flow 1, flow 2, flow 3. Any flow executes, only when action is performed. Observe here, first flow. For the first flow, right? I'll say like R7 dot action. R7 dot action means it flow executes from R1, R2, R3, R4, R7. When R2 is ready, R1 gets removed from the RAM. R2's output is taken as input by R3 as input, right? R3 is there, right? When R3 is ready, R2 gets removed from the RAM. When R4 is ready, R3 gets removed. When R7 is ready, R4 gets removed, right? When total the execution is completed, this R7 also removed, right? Everything got removed, nothing in the RAM now. No RTD in the RAM. Second flow to execute. Second flow, right? Yes. Again, I say, right, R8 dot action. Whenever I say R8 dot action, the flow starts from that root, right? R8, R1 to R8. When R2 is ready, R1 gets removed. When R3 ready, R2 gets removed. When R5 ready, R3 gets removed. When R8 ready, R5 gets removed. When total execution completed, R8 also, no RTD in RAM. Third flow, if I want to execute, see how this data flow gets executed. And third flow, right? R9 dot action you perform. Action means collect a count like that. R1, R2, R3, R6, R9. When R2 ready, R1 gets removed. When R3 ready, R2 gets removed. R6 ready, R3. When R9 ready, this one. Once the execution finished, right? So in this, what is your observation in all this, right? The first three, they are common, right? Even though they are common, still they are re-executing from the starting. R1, R2, R3, R1, R2, R3, R1, R2, R3, right? So just observing this. Here in all the above flows, right? Here in all the above flows. Flow is re-executing from the beginning. In all the above flows, flow is re-executing from the beginning. Even though the first three. So to avoid this, right? To avoid this, identify the RTD, whose output is so to avoid this, identify the RTD whose output is commonly used. Whose output, right? Many flows. Whose output is commonly used by many flows and persist it. So that it will be available in RAM and gives output. Provide this identify the RTD whose output is commonly used by many flows and persist it so that it will be available in RAM and gives outputs to the next flows. Other flows, right? Yes. So in the above example, if you observe this above example, right here, R3 output is mostly used by 3 flows. So R3 need to be persistent. R3 need to be persisted. R3 output is used by in our example, R3 output is used by many flows. So make so in the so R3 output, okay. How to make R3 as persist means RTD3 dot persist R3 sorry R3 dot persist. This is the way, right, for persisting an RTD. Persisting means making the RTD available even its next RTD is ready, even its next RTD is ready, right? Yes. Even if its next RTD is ready. So that to give the output to the other flows. R3 remains in RAM even its next RTD is ready. And provides its output as input to the next flow, right? Now see this diagrammatically the same previous example. There is your flow R1, R2, R3, R4, executing flow 1, right? Yes, you say like R7 dot collect. Then it executes from starting R1, R2, R3, R4, R7. When R1 ready, when R2 ready, R1 gets removed. When R3 ready, you persist this. You are going to persist it, right? When R3 is ready, R2 removed. When R4 ready, R3 not removed. When R7 ready, R4 removed. When execution finished, now R3 remains in RAM. R3 remains in RAM. Flow 2, if you see this flow 2, right? I need to say R8 dot collect or action. So what it checks first? No need to re-execute from the starting. R8 input is what? R5. R5 input is R3. R3 available. So the flow is right from R3 to R5 to R8. Small flow, right? When R8 ready, R5 get removed. Now R3 remains. R3 remains. When R8 ready, R5 removed. When the total execution finished, R3 remains in the RAM, right? Yes. Observe this flow 3 and try to say me, right? Flow 3, you say what is R9 dot collect some action. R9 input is what? Try to answer. R9 input is what?
R6.
R6. Or R6 input is what?
R3.
R3 available, right?
Yes, sir.
So the flow is from R1, sorry, from R3,
R3 to R6.
R6 to R9,
R6 to R9.
R6 R9. When R9 ready, R6 got removed. When total this also gets removed. Now what is present in the RAM? Now what exists in the RAM?
R3.
Okay. So in all the above three flows, even the flow execution is completed, still R3 remains in the RAM.
Yes, sir.
R3 remains in the RAM. Once your action, everything done, everything is finished, right? But if you still, if it doesn't want R3 to be in the RAM, if R3 is not required, okay, if persisted R3 is not required, if it is not required, if persisted R3 is not required, then forcefully we can unpersist it. And then forcefully we can unpersist by saying R3 dot unpersist. Three ways to unpersist an RTD. Three ways to unpersist. Forcefully unpersisting by saying R3 dot RTD dot unpersist. When session is closed, if server shutdowns. Okay, so this is what persisting understood, right? So what happens? So this is what I was talking. Spark data objects are called RTDs. RTD is divided into partitions. The partitions are distributed across multiple RAMs of multiple nodes, and only RTD by RTD executes. RTD is subdivided into partitions. Only the partitions can be executed parallelly, and RTD is transformations and actions. Transformations, if you apply, the resultant also is at RTD, but actions, when you perform actions, you won't get an RTD. Whenever you perform any action, then only the root RTD executes, right? Then the entire flow executes from the root. Some of the transformations like each element filter and aggregated, and some of the actions. Okay. Okay, understood, right? Any queries you got in this, anyone?
Sir, what about this when session is closed? That SC Spark.
So when session is closed, if server shutdowns, right? Totally
Yeah.
nothing, everything will be removed from the RAM. Nothing will be available in the RAM, right?
So what is this session like? When it starts?
Session, okay. Spark context, Spark sc.stop, you say last. Spark context will start it, and at the last we say sc.stop.
Okay. So sc.stop we do, or means
We will be doing
okay.
two situations, right? Two situations. Try to say two situations where RTD will be removed. Where RTD will be removed from the RAM. The situations where RTD will be removed from the RAM, right? What are those two? Whenever next RTD is ready, the previous RTD will be removed from the RAM. When execution is completed, the last RTD okay, fine. So more on this RTD computations, more on this persistence we'll be discussing in the tomorrow session, right? So if any queries as part of today's session, anyone like RTD computations I was discussing, I was just briefing you that introduction of Spark, why Apache Spark, evolution of Spark, and why Spark need for PySpark, right? Spark API, and why Python and Scala, PySpark features, real-time use cases, why Python, right? And PySpark is mainly designed for what features and resilient distributed data objects, right? Okay.
So Spark, when a Spark object is creating, that we call it as a RDD, right, sir?
So when we load data, right, using
Yes,
Spark context, if you load data, then a RTD gets created.
Yeah, yes, sir.
Using Spark context, if you load a file,
Okay.
then a RTD is created. Then on that, on that RTD again, if you perform any transformations, action, filtering, then RTD2 gets created.
Yeah. No, is there any specific purpose we call it as a RDD? I know some naming conventions, resilient distributed data set in the sense. Is there any specification or something when we are creating a Spark context using file load or something, it will create the RDD.
Hmm.
That is some naming convention as per the standards or something. Why
Any,
we
any,
exact?
any name we can give for the .td, not right, or one or any name, right? So again, on that .td, if you perform any transformations, means filter, grouping, aggregations, anything, the result what we get when we perform any transformation on a RTD is also a RTD.
Yeah, sir. No, is there any meanings, a special meaning, resilient distributed data set, something? Is there any special meaning, or just for naming convention that's sufficient?
Resilient distribute, yeah, they are distributed, right? Distributed data sets, right? They are distributed, means they are going to be stored across multiple RAMs, right? Multiple machines.
Yeah. What about resilient, sir?
Yeah, resilience, I'll be saying you in the fault tolerance, you'll understand much better. The tomorrow session, I'll be discussing about the fault tolerance. You can understand the resilience feature.
Yeah. Thanks,
Okay.
sir. So sorry, actually today I don't know. That's Zoom link will be the same. I have paid whatever the money fully, that one. But today I got a bit late Zoom link, so I joined a bit late. So from tomorrow onwards, link will be the same, or they're going to send dynamically every day before class starts. Sir?
Yeah, yes. Tomorrow you can follow the same link. Tomorrow you can
Okay.
follow the same link, but later you'll be getting a new link, right? So for those who got enrolled, who got from tomorrow is Sunday, right? Tomorrow also you can just follow the same link, everyone. From the next
Yeah,
week
I already
onwards-
enrolled, sir. I already enrolled because today I got a link a bit late for me. I don't know, due to some network issue.
I think if you see those, if you got paid the fees, try to share the screenshot of that, right? So that then only they can share that. If you're not paying that, if you're not sharing the screenshot of your payment, right?
No, sir. I already followed what are they given the process, right? I make a payment and send the screenshot to the
Okay,
person.
okay, follow. Okay, you can follow the video, right? You'll be getting the video sessions of this. You can just to go through the, if you have missed the session, right? So only, okay, from there onwards, from next Saturday onwards, right? The same link will be followed up to the end of the course.
Yeah. Then that
And
will be okay.
next Saturday, a WhatsApp group will be created for you. For if you got any problems, you can just post in that, or for any technical discussions or any
Yeah.
other stuff, that will be there. And also the same link for next Saturday, a new link you will be getting. The same link will be followed up to the end of the course, right?
Okay. Thank you, sir.
Okay, tomorrow you can follow same today's link only tomorrow.
Yeah.
But from next week onwards, a new link you'll be getting, right? Yes, fine. So I'll stop here for today. Meet you in tomorrow same time at 3 p.m, right, to see more on this, right? Fine, thank you all for your time. Thank you. Yes.
Thank you, sir.
Hello. Thank you, sir.
Yeah, any queries you got? Yes,
Sir, what about day after tomorrow?
only like class will be on Saturdays and Sundays, right? This weekend batch.
Okay.
So from
Okay, sir.
next week onwards, your timing will be from 3 to 5, right?
Next week it means from Monday.
Next week means like next Saturday and Sunday.
Oh, okay, sir.
So it's a weekend batch next Saturday and Sunday. Okay, fine. So I'm stopping here. We'll continue tomorrow at same time.